Welcome to this explainer. Let's jump right in. Today, we're diving into the absolute magic of Livecraft Sound Color, or neiro for short. This isn't just about passively watching visuals on a screen. It's about unlocking your power to actually create them. Especially if you're a complete beginner, we're going to break down exactly how you can write your own scores and build custom, real-time visuals from scratch.
Imagine this for a second. What if you could take your absolute favorite song and instantly turn it into vibrant colors and shapes? I mean, it sounds like a superpower, right? Well, with Neiro, you can do exactly that, transforming the sound you hear into dynamic visual art. And the best part? You don't need any sort of advanced programming background to pull it off. So here's our roadmap for today. We'll step into the Neiro world, see how sound connects to visuals, go over the score editor basics, learn to write DSL formulas, add original images, and finally move toward creating your very own visuals.
All right, Section 1. Into the Neiro world. Meet your new canvas.
Now, this app isn't just making squiggly lines based on volume. It's way smarter than that. It actually uses Google's YamNet AI to classify over 500 different types of sounds in real time, from human voices to guitars, even laughter. Combine that with Meta for acoustic analysis and WebGPU effortlessly rendering millions of particles without any lag. And yeah, all of this is happening right inside your browser. It's literally mind-blowing.
Moving to Section 2. How sound connects to visuals. The blueprint. Before we start writing any code, we need to establish a mental model of how Neiro actually thinks. Think of its node diagram like a painter at work. First, the sound comes in through the ears. That's the sensation. Then, the artist's brain processes it. That's the intermediate layer. Finally, the hand paints it onto the canvas, which is the reaction. It really is that simple. To get a tiny bit more technical but not too crazy, the sensation layer uses simple arrays like XN and YN to listen to audio features and AI classifications. The intermediate layer, or IN, is basically your imagination connecting those data points, and the reaction layer, that's your brush actually hitting the screen, creating the shapes and colors you define.
Okay, Section 3, Score Editor Basic Operations. The tools.
If you're a beginner, don't worry. The workflow is incredibly actionable and hands-on. You just open the editor from the side menu, type out your logic, and here's the magic trick. Press Ctrl plus Enter. Boom, your visual updates instantly. Oh, and you can hit Ctrl plus M to open the monitor panel and actually watch the real-time sensor values shift as you tweak things.
Section 4. How to write DSL formulas. The language. To bridge the gap between sound and visuals, we use a simple domain-specific language, or DSL. It's really just about picking the right numbers. For instance, grab x0 and you get the raw volume on a scale of 0 to 1. But if you call y148, you're literally getting the AI's confidence level that a piano is playing right now. It's so intuitive once you try it.
And here is where the magic really happens. If you just set your brush scale to 1.0, well, you get a pretty boring static image. But swap that out for scale equals x0 times 5.0, and suddenly your brush is pulsing and pumping to the beat of the track. That right there is the exact moment sound and image become one.
To really polish things up, you have some super handy built-in math functions. You can use clamp to keep values in check, or map to shift ranges. But for beginners, your absolute best friend is definitely EMA, the exponential moving average. It smooths out those jarring audio spikes so your visuals don't flicker like crazy. You can even toss in some noise for a more natural, organic vibe.
Section 5. How to add original images. The personal touch.
To truly make this art your own, you can easily bring your own custom SVG shapes into the mix. The coolest part? When you sideload a local SVG file into the editor and save it, Neiro automatically embeds that image data directly into your TOML file as text. You don't need to zip up a bunch of image folders, just share that single self-contained file and anyone can play back your exact visual masterpiece.
Finally, Section 6, Toward Your Own Visuals. The reward. Just look at the insane diversity you can achieve once you start applying these basic principles. You've got Manamo, with these beautiful abstract brushstrokes that shift color based on pitch. And right next to it, Wonko, which looks like a fully animated character jamming on a guitar. They look completely different, but guess what? They are driven by the exact same underlying node logic.
You can push it even further, too. Check out the BOBU score. It uses multiple custom SVGs to create these incredibly intricate, overlapping floral designs.
You can literally program specific flowers to bloom when a certain frequency hits or when a specific instrument plays. There are absolutely no limits to the visual aesthetics you can achieve.
And here is perhaps the biggest takeaway for you as a creator. You aren't just playing a game here, you are authoring original digital art. The copyright for the scores you build belongs entirely to you. You own it. You can share it, publish it, and proudly claim it as your own unique work.
So, you've got the blueprint, you know the score editing tools, and you've learned the language to build your own visualizer from the ground up. The rest is entirely up to you. Think about your favorite track. What color and what shape is your sound? Dive into Neiro and show us. Thanks for joining me on this explainer today.